All right, here we're looking at section 6 in our algebra review section. So the big thing is in this section we're going to be solving different equations. So our learning targets, we're going to solve these equations by factoring. Then we're going to look at some absolute value equations. Then we're going to look specifically at quadratic equations, and we're going to solve those by factoring, then by completing the square, and by using the quadratic formula. So just remember that all three of these ways work for all quadratics. It just depends on which one is easiest and most useful for each individual problem. So the first thing we want to look at is we're dealing with some equivalent equations until we find one that we can actually solve and deal with. So let's look at what we mean. So one thing we can do is we can simplify, right? We can always look backwards and forwards as long as you have that equal sign. I can simplify to help me get some easier numbers and values to work with. I can either add or subtract the same thing on both sides. Same thing with multiplying and dividing to get rid of some values and things. And then I know my zero product property, that if I have two things that are multiplying to equal 0, then I can set them both equal to 0 and solve for that. So here's our first example to solve this equation. Hopefully you can do this in your sleep. So I see I'm trying to get x by itself, so the first thing I want to do is add 5 to both sides, because what I do to one side I have to do to the other. So I end up with 3x equals 9. Now I see I'm multiplying, so to undo that multiplying, I divide by 3, so I end up with x equals 3. Simple as that. We will be solving much more complicated equations, but we need to know that the biggest things are we're undoing what's already being done. That's how we're solving for these variables. Okay. So now we're going to look at some factoring. So we're going to solve these different equations by factoring. Okay. So the first thing we always have to do is get everything on one side, and so I have a 0 on the other, and then I can start factoring. So this one I notice, once I get everything to one side, I see that I have an x in each term, so I'm going to go ahead and factor that out. So I pull my x out, I'm left with x squared minus 4. Well, now I see that this is the difference of two squares, so I can go ahead and I factor that again. So I end up with x times x minus 2 times x plus 2 equals 0. So when I'm factoring, I want to get the equation down, broken into as many pieces as I can. So now I'm going to use the zero product property, right, now that I have it broken down, and set each single piece equal to 0 and solve for all of them. So now I have all of my different solutions. So I see x equals 0, or x equals 2, or x equals negative 2. So those are all of my possible solutions for this equation. Okay, so then we can just double check and look through it again. So now let's look at that second polynomial that we were looking at. So the first thing I want to do is I want to make sure that I have it kind of written out as I need to be. Then I'm going to group this. Okay, so I group my first two terms together, and then I group my last two terms together. The biggest thing here when I grouped these second terms, you'll see I grouped it as 4x minus 4. That's because I pulled out a negative 1. If I was to distribute this negative 1 inside, I would end up with exactly what I have above. So now that I have each set grouped, now I can factor out the things that are common in each of those groups. So I see I have x squared in both of these terms, and I have a 4 in both of these terms. And I went ahead and grouped them because I noticed I would end up with an x minus 1 and an x minus 1. If these two things inside your parentheses are different, then we know we need to go back and start again. But since here they're the same, I can go ahead and write out my common factor. So I have my x minus 1, and I have x squared minus 4. Well, I notice again that I have the difference of two squares. So I've got x squared minus 4, which I can then factor out to x minus 2 and x plus 2. Well, now that I just have everything as broken down as I can and equal to 0, I use my zero product property and set each piece equal to 0 and then solve for my x. So that's how we just do some factoring, just simple factoring and solving. So now we're going to look at some absolute values. So the only weird thing with absolute values is I'm going to have two solutions, because I always want to think of my number line, right? So this is what we're dealing with at absolute value. So absolute value tells me how far away from 0 I am. So the way I like to think of an absolute value is how many steps away. So if I go over here, I'm 2 steps away. So my absolute value here would be 2. Again, even if I'm going towards the negative side, I'm still taking 2 steps. So the absolute value of a negative 2, it took me 2 steps to get there. Okay, so now let's look at how we can solve some of these kinds of problems. So I'm always going to have two possibilities. So the first thing I do is I set up my equation, everything that was inside the absolute value sign and everything that was on the right side, just as it is, and then I set up my second equation. So you'll notice the only thing different here is I have this negative in front of the 13. So I'm always going to have my whatever was inside the absolute value equal to a positive, and whatever's inside equal to a negative. And then I just simply solve both of these, and those are my two solutions. So now we're on to that last little group of learning targets was dealing with solving quadratic equations. So I can solve quadratic equations three different ways. First is factoring, and the second is completing the square, and the third is using the quadratic formula. As long as you are very comfortable with at least one of them, you're in a good spot. So let's look at some factoring. But first we need to figure out what a quadratic is. So a quadratic means I have the x squared term is the highest exponent that I have. So then I also have a, b, and c are real numbers. Okay, so that's just the biggest thing about a quadratic. So now let's look at this one. So I've got 2x squared equals x plus 3. First thing I want to do is I want to get everything to one side and put this in standard form. Standard form just means I go from the highest exponent to the lowest exponent. So now I just go ahead and subtract both of these, the x and the 3 from both sides, so I end up with 2x squared minus x minus 3. From here I can then factor this out. So I want to come up with the factors of 2 and the factors of 3 and see how I can break this down. I want to break it into chunks. So once we're factored, now I can set each piece equal to 0 and solve for my x values. So these would be the solutions to my quadratic equation. Okay. So again, let's look at this factoring one. So this one's already in standard form, so I don't need to do anything here. So I can go ahead and factor. The thing I notice about this one is this follows one of my just general rules, because I know the square root of 9 and I know the square root of 1. But I also notice that the square root of 9, if I multiply that times 2, will give me this middle term. So I know I can use that to help me factor this out. So I end up with 3x minus 1 times 3x minus 1 equals 0. So that's the same thing, so I just set up each piece equal to 0 and I solve for it. This is what we call a double root, because it's the same answer both times. It's just a double root. Okay, so here's something we're going to really keep in mind. So if I've got x squared equals p, when I take the square root of something, so in this case I take the square root of p, I always have a positive and a negative. This will come into play a lot later on, but for now just remember, when I take the square root I have plus or minus. Okay, so now we're going to be completing the square. So the first thing I always want to do in completing the square is write, so my constant, right, the thing without the variable, is on the right side by itself. Okay, so I went ahead and I added 5 to both sides. So now I can get rid of this 2, because this coefficient, the coefficient in front of my x squared, needs to always be 1. So this can be one of those hints on, should I use completing the square? If this coefficient is not 1, I would skip that, because you're going to add extra steps. But we're going to still walk through this one. So I'm going to divide everything by 2, so I end up with that coefficient of 1. So I end up with x squared minus 4x equals 5 over 2. So the next thing I do is I'm going to start working on completing the square now. So I'm going to add 4 to both sides. And where I get 4 is I take this middle term, this b, right? And in this case it's negative 4. And I divide that by 2. So when I divide a negative 4 by 2, I end up with a negative 2. And then to get this 4 that I add in, I square that. So I divide by 2 and square it, and then I add that to both sides. So that's where this pink 4 came from. So now I can go ahead and actually complete the square and write out my factored form here. So you'll see I can just add the values that are on the right side. So where did I get this negative 2 from? Well, when I do this division, I divide that b term by 2. That's what goes right in here when I factor it out. So now that I've kind of factored and simplified, I can take the square root of both sides, right? Because I just have something squared equals a constant. I take the square root of both sides. Here's that plus and minus when I'm taking the square root. So then I just add 2 to both sides and kind of simplify my fraction as I go. Okay, so that's completing the square. We really will not use that as much. It can add a lot of steps and be a little more difficult. The biggest thing you really need to know is the quadratic formula, because this quadratic formula will work on any quadratic problem anytime you need it to. It will always work. Okay? So here's my quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Hopefully this is in your brain. There are some magical, wonderful YouTube videos that sing the song that you will never forget. So try that if you have trouble remembering this. Okay? We're also going to be talking about the discriminant. So you'll notice this b squared minus 4ac is the stuff that's inside your radical sign. Okay? So if I take that b squared minus 4ac, if that's greater than 0, there's two solutions. If it equals 0, there's one solution, that double root that we looked at earlier. And if it's less than 0, there's no real solutions. So that will come into play as well. So here we're going to go ahead and use the quadratic formula on this quadratic. Okay? So I always want to make sure I'm in standard form. So I look like ax squared plus bx plus c. Then I can find my a, b, and c. So I see here my a is 3, my b is negative 5, and my c is 1. And so now I can check out my discriminant. So I just plug in those values, and I get 13. 13 is greater than 0, so I know I'm going to have two solutions. So now I just plug in my numbers into the quadratic formula, and then I simplify and solve. Once I reach this point, since I don't know the square root of 13, I just leave it alone. I do not give myself decimal answers. I leave these as exact as I can. So these are my two solutions, right? Because I have 5 plus the square root of 13 divided by 6, and then I have 5 minus the square root of 13 divided by 6. So those are our two solution sets. Okay, so here's our next example, and we're going to be using the quadratic formula again. The first thing we notice is this is not in standard form, so we have to put it in standard form by subtracting 4x from both sides. Now that we're in standard form, now I have my a, b, and c. Now I can find my discriminant. My discriminant here is a negative, so I know that there's no real solution. And at this point, I can just leave it like that. I don't have to actually solve it anymore since we're not dealing with imaginary solutions yet. You will be, but not yet. So let's look back at our learning targets. First, we solved some equations, simple equations by factoring. Then we looked at those absolute value equations. And then we talked about the 3 different ways we can solve a quadratic equation. The biggest one here is you must know how to use the quadratic formula, because that can be used on any quadratic equation and will always work for you. So now that we've gone through all of these learning targets, go ahead and work on your homework for this section.